Good morning, everyone. This is Kirtana, Assistant Professor, Department of Information Technology at K.S.Rangasamy College of Technology. Today, I'm going to explain about the most critical components of modern networking, that is TCP connection and TCP congestion control. The introduction to TCP. TCP stands for Transmission Control Protocol. It is a connection-oriented protocol. It ensures reliable data transfer, uses error checking, and flow control. This is a foundational how to reliable communication works over the internet. Let's begin with the basic of TCP connections. TCP connection establishment. TCP features are reliable delivery, ordered data transfer, flow control, congestion control, full duplex communication. Next one, connection oriented services. The TCP is a connection oriented services. It is used by major internet applications like HTTP, FTP, email, etc. It guarantees both sender and receiver are ready. It uses three-way handshaking protocols. That is, the process of establishing a TCP connection involves three-way handshake. That is, synchronization acknowledgement, third one, acknowledgement. It establishes a full duplex connection. The first one, synchronize. The client syncs a TCP segment with the synchronize flag set to initiate a connection. This segment includes the client's initial sequence number, that is ISN. Second one, synchronize acknowledgement. The server responds with a segment that has both synchronize and acknowledgement flag set. It acknowledges the client synchronization and sends its own ISN. The third one, acknowledgement. The client replies with an acknowledgement, the server's synchronization. At this point, the connection is established and the data transfer can begin. The next one, TCP segment structure. Each TCP segment includes source and destination port. It is header plus data. Header includes port, sequence number, flags, important for managing connection and flow. The sequence and acknowledgement numbers, flags, that is synchronization, acknowledgement, and fin. Window size for flow control, optional fields, and a payload. Now, once a connection is established, the primary challenges is how to manage a congestion. The next one, TCP congestion control. Congestion occurs when too much traffic is offered to a network link than it can handle. TCP includes congestion control algorithm to prevent this. Let us look at the key concept of algorithm used by TCP. That is, the four components of congestion controls are slow start, congestion avoidance, fast retransmit, fast recovery. The first one, the slow start. When a TCP connection starts, it does not know the available bandwidth. Instead of sending a full stream immediately, TCP starts cautiously. Initial congestion window typically starts at one or few maximum segment size. Exponential growth. For each acknowledgement received, congestion window increased by 1, so the amount of data in flight doubles each round trip time, that is RPT. This continues until a loss occurs and it reaches a threshold called slow start threshold. If packet loss is detected, TCP assumes the network is congested. The next one is congestion avoidance. When a congestion window reaches this threshold, TCP switches to a linear increase. For every RTT, congestion window increases by 1, not exponentially. This allows TCP to prompt the network capacity more cautiously. If congestion is detected, that is usually by packet loss, TCP reacts more conservatively. The next one, fast retransmit and fast recovery. Sometimes TCP detects loss not by a timeout, but duplicate acknowledgements are occurred. Fast retransmit the sender receives 3 duplicate acknowledgements, it immediately retransmits the missing segment without waiting for a timeout. The fast recovery. TCP cuts congestion window by half instead of starting from 1. Sets is crushed to half of congestion window. Temporarily inflates congestion window to keep the pipeline full and avoid stalling. Returns to a congestion avoidance after the recovery. This mechanism helps maintain higher throughput and reduce idle time. Then TCP congestion control phases. TCP congestion window. It controls amount of data sent, adjusted based on the network feedbacks, grows or shrinks with the congestion control. The next one, threshold value. It marks switch between slow start and congestion avoidance, updated after the congestion window. Additive increase. Increase congestion window by 1 segment per round trip time, ensures network stability. The TCP establishes the connection using three-way handshake. Once the connector, it ensures reliable delivery and control congestion to avoid overwhelming the network. The key congestion control mechanisms are slow start, congestion avoidance, and fast retransmit for quick response to a packet loss. The multiplicative decrease, it reduces the congestion window sharply on congestion. Typically, congestion window is divided by 2, helps recover gracefully. TCP Reno versus TCP TAFIO. 2 variants of TCPs are TCP TAFIO on loss congestion window set to 1 MSS. Restart slow start. The TCP Reno, it implements the fast retransmit and fast recovery, so it's more efficient in handling signal packet losses. Newer TCP versions, example QB and BBR, it improves the performance further in modern high bandwidth network. Then modern variants, CCP, VGAT, VBR, Cubic, etc. It improves the performance of. Then conclusion. TCP ensures reliable congestion-aware communications. It uses dynamic algorithm to adapt to network key protocols for the internet. The summary of TCP congestion control is it establishes the connection using three-way handshake protocol. Once connected, it ensures the reliable delivery. Then it controls the congestion avoidance. The key congestion control mechanisms are slow start, it ramp up the data transfer. Then congestion avoidance, it is mainly used for steady growth. The third one is fast retransmit or recovery. It is mainly used for quick response to the packet losses. These strategies make TCP both robust and adaptive in real-world network conditions. Thank you.